So today we're finding the exact value of the cosine of 105 degrees using half angle identities. Now the nice thing about Module 5 is that it will tell you which formula to use. So since we're using half angle identities, please note that the exact value means the fraction form. So whatever I pick needs to be from the unit circle. Now a shortcut to this is, since it's using half angle identity, I take the given angle and I multiply it by 2. So always take the angle, multiply it by 2 when given half angle identities, and that will tell you the angle you're going to use in the formula for theta. And the reason for that is because if you look, theta divided by 2 should give me 105 degrees. So I'm just going to work backwards. I'm going to multiply it by 2 to find out what divided by 2 will give me 105 degrees. So now that I know that I'm using 210 degrees, which is in the unit circle, I'm going to write my formula. 210 degrees over 2 equals. So you have a positive and negative in front of this formula. You are not using both positive and negative. It just depends on the angle given to you. So please note that the angle given to you is 105 degrees. Reviewing Module 4, all students take calculus, little acronym for what's positive in each quadrant. 105 degrees is in the second quadrant where only sine is positive, which means my cosine value is going to be negative. So I'm only using the negative. And plugging in the rest will give me 1 plus cosine, remember theta is 210 degrees, over 2. So I'm going to apply the unit circle and figure out 1 plus cosine of 210 degrees would give me negative square root of 3 over 2, all over 2. So take your algebra, and just solve for the numerator first. So I'm going to take a sidebar up here, 1 minus square root of 3 over 2, because 1 plus negative just means 1 minus. And I think we can all agree that instead of using the 1, I'm going to change this into 2 over 2, which is still 1. But in this case, I can apply common denominators. So solving for the numerator, or simplifying the numerator, I'll get 2 minus square root of 3 all over 2. And I'm going to bring this back down. So I'm going to bring down the negative, bring down the square root. 2 minus square root of 3 over 2. Remember that the denominator is also all over 2. So I'm going to bring that down. And now I'm going to divide these fractions by using keep, change, flip. So I'm going to take the numerator, 2 minus square root of 3 over 2. Keep it, change it to multiply, and flip the 2, whose fraction form is 2 over 1. So when I flip it, I'll get 1 over 2. So to multiply fractions, we go straight across. And I'm going to get 2 minus square root of 3 all over 4. So bringing this whole thing over, 2 minus square root of 3 over 4. Now, fun fact about fractions. When you have a radical or a square root over the fraction, you can square root each one individually. Meaning I can square root the numerator individually, which nothing happens because I can't square root this, 2 minus square root of 3, over, but I can square root the 4. Square root of 4 gives me 2. Final answer, exact value, fraction form. Hope this helps.